So we're going to find a transformation that reflects in the line y equals negative x plus 1. So we can't do that yet. We need to do some sort of combination thing. Now we have this. Y equals negative x plus 1 is a line that looks like that. And we want to reflect in that line. Now, we know how to reflect in lines that pass through the origin, but we don't know how to reflect in lines like that. So, similar to a previous one, we're going to move that line down, reflect, and move back up again. So that's going to be our three-step process. So that means that our image is going to be equal to, now there's going to be like a reflection matrix. We'll deal with the reflection matrix in a minute. We're going to multiply it by a point, but we need to take that point, or the plane really, and we need to take the plane and move it down by that amount. Because if we move it down there, then this line will now be passing through the origin. So for this particular example, we need to have x and y minus 1. Because we've got this plus 1 here, so that means that our y-intercept is plus 1, and we want to move that y-intercept down by 1. Okay, now we need our reflection matrix here. Cos 2 theta, sin 2 theta, sin 2 theta, negative cos 2 theta. We'll deal with the theta in a second. And then finally, once that's all done, we moved it down, we reflected it, and now we're going to move it back. Plus, now we're not moving the x-coordinate at all, but we are moving the y-coordinate back up by 1. So now we have step 1, step 2, step 3. So before we do the calculation, I just need to know what that theta is. In other words, I need to know what that angle is there. Now we know that tan theta equals m, and m in this case is negative 1. And then theta will be equal to, in this case, negative 45 degrees. Which means that this is 2 theta, which is 90 degrees. So now I can do that, and I will just do that in one step. So cos negative 90, sine negative 90, sine negative 90, negative cos negative 90. And we're going to multiply that by this matrix here, x, y minus 1. And then we'll add back on that one there. Okay, we're getting pretty close. 0 times x, negative 1 times y minus 1 is negative y plus 1. And negative 1 times x, 0 times y minus 1, I get negative x there. And we're going to add 0 and 1 to that. Which means negative y plus 1 plus 0 is just negative y plus 1. And negative x plus 1 is negative x plus 1. And that is our transformation matrix. We can sub any point x and y in there, and we'll get our image x dash, y dash. I can probably verify that for you by just choosing this point here, 1, 1. Now, if we reflect the point 1, 1 in there, it's pretty obvious that we're going to get to 0, 0. So let's just see if that works using our formula. The image will be equal to negative y plus 1, negative x plus 1. And then we sub in our points 1, 1. So negative 1 plus 1, negative 1 plus 1. We get the point 0, 0 for our image, which is exactly what I expected. So I feel like we're good to go. So another 3-step process you can see. And this is generally how we can do things here. We just move ourselves down to the origin, do whatever we want to do, and then move back to where we started from again.